Hi everyone, and welcome back to grade 12 maths with Mr. Simons, where we make maths simple and get you exam ready, right? So now we're looking at the fifth variation of diagram sums, and that is where we have to write our problems in terms of a variable given. Specifically looking at the November 2016 paper and the November 2015 paper. Right, so let's look at the problems before we attempt solving them. So November 2016, question 5. Given sine 16 degrees equal P. Determine the following in terms of P without using a calculator. Sine 196, cos 16. Right? Look at November 2015, also question 5. Given that sine 23 equals square root K. Determine the following in terms of K without using a calculator. In its simplest form, we want sine 203, cos 23, and tan negative 23. So I specifically chose these two to show you that sometimes give you the variable and we can give you the square root of the variable. This slightly changes certain things that we're going to find. So we're either going to test it straight out, just giving you one variable, or square root of the variable. Right? So our objective when you see the sum is whether we can write this in terms of being 16 degrees. This here, because I have 23, I have to write everything else in terms of 23 degrees. Right, so can pause here, look at your problems, try to solve them, see where you've gone wrong, so you can practice that error out of you, right? Right, so let's look at the first problem. Given sine 16 degrees equal to P, determine the following in terms of P without using a calculator. Right, now I've just done a diagram for some of you because I'm not sure whether your teacher has shown you this. Sine 16 there, when I write P, is the same as saying P over 1. Remember, anything divided by 1 stays the same. So then technically we should remember that sine is Y over R. So my Y value here is P and my R value is 1. This drawing there, 16 degrees, is acute angle, so it falls in the first quadrant, right? So we need to find X, right? But that there is just to show you how I can take this and write it in diagram form. So 196, I need to make it read as 16 degrees. So 196, remember 0 to 90, 90 to 180, 180 to 200. So 196 falls in the third quadrant where it would be 180 plus. So 180 plus 16 degrees gives me 196. Third quadrant sign is negative according to the cast rule. So that would give me then negative sine 16 degrees. Sine 16 is P, so therefore that becomes negative P. One mark for negative sine, another mark for negative P. Now for cos 16 then, can go two ways about it. Now you still remember the square identity says cos squared plus sine squared equal 1. Now if I modify that, I can say cos squared equal 1, and if I take sine over, minus sine squared 16. So to get to cos 16, I'm going to say square root of cos squared 16 gives me cos 16, square root of 1 minus sine squared 16 degrees. Now 16 sine 16 is P, so that sine squared 16 simply becomes P squared. So this equation then reads cos 16 equal 1 minus P squared. Right? Or if you want to go a longer route, first use the theorem of Pythagoras that says my two shorter sides squared, if I add them, must equal my longer side squared. So x squared plus p squared must equal 1. But to get to x, I'm going to take p squared over. That's going to become 1 minus p squared. And to get from x squared to x, I need to find the square root. So that is square root of 1 minus p squared. So 1 mark there for 1 minus p squared. Right, so cos 16 degrees then technically would then be my x value over my r value, which then is square root 1 minus p squared over 1, and anything divided by 1 stays the same. So that becomes 1 minus p squared. Right? So if sine 16 is p, then cos 16 would be square root of 1 minus p squared. If I said sine 50 equal k, then cos 50 would be square root of 1 minus k squared. right? So whether we draw it and so on, that is always what would happen. Right, now let's look at the second one where we actually catch learners out, because as teachers we have the bad habit of saying, now just memorize. If sine 16 is p, then cos 16 would be 1 minus p squared. So then we throw a spanner in the wheels, and instead of saying p, we say square root p. So let's look at the next exam question. So November 2015, question 5. Given that sine 23 degrees is equal now square root k, determine the following in terms of k without using a calculator in its simplest form. So sine 203, I must make sine 23. So that is 180 plus 23 in the third quadrant, right? In the third quadrant, sine is negative. So that becomes negative sine 23 degrees, 1 mark, which then becomes negative square root k. Cos 23, as I said, if sine 23 is square root k, then I would have just written square root of 1 minus k squared, but it's not the case. So the cos squared 23 degrees equal 1 minus sine squared 23. So that gives me the square root of 1 minus sine squared 23, which then becomes square root k squared would simply become k. So now it becomes square root 1 minus k. Or if I said here in my diagram, remember square root k over 1, square root k represent y and the 1 would represent r. There's my 23 degrees, so to get x, say x squared plus in brackets square root k all squared equal 1. Take that over, it will become minus square root k squared, square root of that, so squared of square root k would simply then become k. So cos 23 equals square root 1 minus k over 1 equals square root 1 minus k. So I hope this makes sense to you and it's clear to you. Now, we look at the third problem here. Tan negative 23, so negative angle we take as being in the fourth quadrant. In the fourth quadrant only cos is positive, right? So tan becomes then negative tan 23, right? But there, because I have sine and I have cos, I'm going to work with sine. Or I could have gone straight negative 23, so 23 degrees there, tan is y over x. So it's be square root k over square root 1 minus k squared. Right, but here, minus sine 23 over cos 23, sine 23 being negative square root k, sine 23 being square root k, and cos 23 being square root 1 minus k, which then becomes negative. Second law of surds, I can put them all under one square root sign and become k divided by 1 minus k. So 1 mark for sine 23 over cos 23, second mark for final answer, or 1 mark for writing it straight from there, and a second mark for simplifying. So I hope you follow, you understand. So as I say, this is the fifth variation, and I hope it makes sense to you. So that's the basic 5 ways we change diagram sums, trying to catch you out. Don't now be not thinking, almost use the word that I hate using because I don't believe in it, right? Continue practicing, but make sure you understand the variations. You see here under trig diagrams, I've done all 5 variations, right? So that you don't get stuck when we change how we test it. The procedure stays the same. The testing, we change slightly, trying to catch you out. Make sure you practice and understand the variations. So diagram sums, 5 variations, right? God bless. Bye.